Question number one, children. A liquid is heated in a beaker, and the density of the liquid changes as its temperature increases. This causes energy to be transferred throughout the liquid. How does the density change, and what is the energy? What is this energy transfer process? You are heating a liquid, children, in a container, and they said density change. Density will change as its temperature increases. You are providing a heat to the water in a container. Temperature will increase and density will change. So you have to find out how the density change and what is this process involving here in heating the water in a container. So in options, you can see density either it will increase or decrease. So you have to find out the right answer. So here, children, water is heating, volume is expanding, expansion is taking place, volume is increasing. By assuming that the mass is constant, then you can remember a one equation: density is given by mass per unit volume. As the volume is increasing, so the density decreases. So I can see that the density decreases in option A and in option B. So it means you can eliminate option C and option D. So what process is taking place in liquid? Is this conduction process or convection? Now, water get heated, children, by the process of convection. So the right answer is here, option number B. Jasmine said this is B. Yon Kim said it is B. Correct. All of you children, you can send your answers. Question number two, children. Question number second. A rod is made half of glass and half of copper. Means one side of this system is a good conductor of heat and one is a bad conductor of heat. Four pins are attached A, B, C, D to the rod by wax. The rod is heated in the center. The heat is provided at the center of the system and the pin starts falling, So which pin fall off first? Which pin? Now you can see that the heat is provided at the center. Here heat is provided. So when the heat is provided, so copper, it's a conductor, is a good conductor. So the heat will transfer fastly from to the right hand side as compared with to the left hand side. So in the right hand direction that we have pin C is first, which is attached there by a wax. So as the heat is transferring faster to the in the copper wire, so the wax will melt and that's why the pin C will fall down. So here answer is children C, and I have given that the explanation why it is C. Let me check your answer. Yon Kim said this is C. Okay, and one student Jennifer C. You won C. Jasmine C. Next question, children. Keep sending your answer, children. All of you, please. All of the students, please involve yourself. Give your answers. Which process involves convection? Which process? Convection, convection process take place in a either in a liquid or in a air. So bread toasting under grill, no, it's not a convection process. Energy from the sun, that is the radiation process. Hot air rising to the top of a cool room, hot air, convection take place in air. Yeah, option 3 I can consider, but let's see what about the D. Thermal energy transfer through a copper bar. Through a copper bar, that is conduction process, children. So the right answer here I can find option C, children. And Charvi said third C, correct. Charvi, Kim Yon, 3C, and Jasmine, Yon Kim. Next question, children. You keep mark these answers, children, in your notes also, so that during exam times you can revise and you can find out the answer also. Arjun, your answer is also correct. Question number 4. Students suggest some uses for containers made from good thermal conductors and for containers made from poor thermal conductors. In which row are both suggested uses correct? Children, for question number 4, take some time. Read the statement, all the options carefully. They are talking about uses of containers made from, some containers are good thermal conductors and some are poor thermal conductors of heat actually. So if we start from option A, good thermal conductor, there's a good thermal conductor, keeping a cold liquid at a low temperature. And poor thermal conductor, this side, transferring thermal energy, children. If it is a poor thermal conductor, then it couldn't transfer thermal energy. So that's why I can remove the option A. And again, if I move to the option B, keeping a hot liquid at a high temperature, it's not possible. That's not the role of a good thermal conductor. If some liquid is put in a good thermal conductor, hot liquid, then the heat transfer take place. Then one in that case. And on the right hand side, say if I see the option keeping a cold liquid at a low temperature, may be possible, but here this side is wrong. If I go to the option number C, transferring thermal energy quickly from a hot liquid. And again, on the right hand side, transferring thermal energy quickly to a cold liquid. Again, this portion is wrong. That's why the option C is also wrong. And if I go with the option D, transferring thermal energy quickly to a cold liquid, yes. Thermal conductor, because heat always flow from high temperature to a body at low temperature. I can find out that the left hand side is correct. What about the right hand side of poor thermal conductor? Keeping a hot liquid at a high temperature. Yes. A poor thermal conductor means a insulation like a thermal flask. So here, children, right answer is here, option D. Let me check your answer. Charu said D. Okay, Charu, good. Shavila said D. Kim on 4D. Jennifer also said 4D. Yes, you will keep sending your answer like 4D, 4C with question number also. Next question. A cotton sheet is ironed with a hot electric iron. How is energy transferred through the metal base of the iron to the sheet? Okay, read carefully all the option and statement. Through the metal base of the iron to the sheet. They are in contact by conduction, by convection, by radiation, or by convection and radiations. Which process is taking place? In a metal base, conduction process, both are conductor. Jasmine Mola said, yeah, it's A, children. No such for explanation, but it is a conduction process in the metal base. Transfer will be heat. No, Kim, it's not say radiations, but it is a fifth A in the metal base that they are talking about. So we will go with the conduction process.
Yes,
Question number 6, children.
sir.
Yes, please.
Uh, just saying, I don't think we have covered conduction, convection, and radiation in depth yet.
Two plastic cups are placed once inside the other. A small spacer keeps the two cups separated. Hot water is poured into the inner cup and a lid is put on the top as shown in the figure. Then Look at the statement clearly, children. Look at the diagram clearly, carefully. Which statement is correct? Hot water is there, small spacer, small air gap, bench. The bench is heated by convection from the bottom of the outer cup. Bench cannot be heated, heat always flow that from bottom to inner convection from bottom to up. And so option A is wrong. The lid reduce the energy lost by convection. Yes, it will do. So still I have to check other option also. I find the right answer B, but let me check why C and D are wrong. There is no thermal conduction through the sides of the either cup. No thermal conduction. Thermal conduction can be take place because this small spacer is there from the body that this small conductor, this small spacer as a conductor, conduction can take place. So C option is wrong. In option D, the thermal radiation is prevented by the small air gap. Air gap is there. You can find that this air is there. But as I discussed just now, children, radiation can pass through air, can pass through vacuum. So radiation, you can't prevent the radiation by small air gap. So that's why the best possible answer is children B. Let me check your answer. Uh, Jenny said B, 6B, came Eon 6B, and Eon came 6B. Correct. All of you, rest of the student, please. Only three students have sent an answer. All of you, please keep sending your answers. Next question, children. Have I discussed this graph in class, children? This topic in classroom, ninth class. You don't know,
Think
children, what's
so. I think so.
okay? So let's discuss this question. A solid is heated from room temperature. This is an important question. The graph shows how its temperature changes with time as it is constant. At which time has it just completely liquid? Look at the graph. At what time it is converted into liquid? At room temperature, that the solid is there, start absorbing heat, then its temperature increases. It leads to suppose 0 degrees Celsius, and then after that, melting process start taking place, and that to melt the ice, latent heat of fusion, some amount of heat is given, and at exactly point C, that the entire ice that the solid will turn into the liquid. The question is at which time it has just completely liquid, at A, at B, at C. So this is the point C, at time C, that the entire solid, that ice will be converted into liquid. If I take the middle point on this line, children, at point B, actually this point, so this is for, I can say that the 50% of water is there and 50% ice is there. Means you can say 50% ice is converted or turned into a liquid. That is, so the question number 7, children, the right answer is at point C. Let me check your answer. And for question number 7, Chuila said 7C. Here said C. Eon Kim C. Kim Eon A. 7A. Kim, you check your answer that not A. At point A, the solid is completely a solid. After that, it starts melting. Next question, children. Question number 8. Thermal energy travels through space from the sun to the earth. Space is a vacuum, okay? How is thermal energy transferred from the sun to the earth? What process? When I was explaining to the radiation process, I told you, children, radiations come from sun, Yeah, it's a radiation process. Question number 8, right answer is children C. Move to the next question, ninth question. The diagram shows a vacuum flask used to keep liquid hot. That is the purpose of a thermal flask. And how does thermal energy pass through vacuum? Thermal energy pass through vacuum. In vacuum, conduction never takes place. In vacuum, convection never takes place. So we have left with only one option, that is a radiation, children. So for question number 9, I will say that the answer is radiation. Good, Jennifer, you came. So let's move to the next question, question number 10. Also pay attention on question number 10, children. Read this statement carefully. Question number 10. A cupboard is placed in front of a heater. Air can move through a gap under the cupboard. Air can move, there is a space actually. Which row describes the temperature and the direction of movement of the air in the gap? Air temperature. Air at the bottom, children. Air at the bottom. Definitely, there is here. What is the purpose of heater? It will heat the warm. It will heat the air. Whatever the air is in its surrounding, so it will heat it, and then the hot air will move upward. The hot air will move upward, children, and the cold air it starts settling down, and that's why here in the space that we have the cold air. So it means I will say air temperature will fall. Where is air, children? Here in this case. So temperature will cool. So it means option C and option D is wrong. So then you have to find out the air direction. It is away from the heater or it is towards the heater. So air, the cold air, basically this is going towards the heater, and the heater, what heater is doing, it's making the cold air to convert into a hot air, and by as it gets heated, its density decreases and then it moves upward or it starts floating. So then we will go with the towards the heater here. The B is the best answer from A and B, and out of these four options. Let me check your answer. Here said B. Yeah, very good here. Yon came that it is 10B. There is one more student. Chavila said 10B. Kim said 10B. And Jennifer also 10B. Good. Rest of the students, Harsh, you are not sending your answer. Charvi, Arjun, Trisha, Satwik, Kevin, Natania. All of you, please keep sending your answer. You can, please. Next question number 11. One method of heat transfer involves energy traveling at a much greater speed than in other methods. What is the name of this method, children? Faster energy transfer take place in a solid, liquid, or gases. Uh, means convection, conduction, or radiation process. The fastest radiations can come from the space from the sun to here in around 8 minutes. So yes, it's a radiations process. I don't want to spend much time on 11. Let's move to the question number 12, children. The diagram shows a block of ice placed in a warm room. At which point is the temperature the lowest? Question number 12, children. At which point the temperature is lowest? Ice cube is there. At A, at B, at C, and D. Ice cube will, ice particles will make that the cold particle, they settle down, the cold particles settle down. So the temperature at A couldn't be higher, cannot be higher at B. Some will be at C, but the coolest, the lowest temperature will be at point D. Yes, Arjun, very good. Jasmine said D, and Yon Kim 12A. A, no, no, no. At A is temperature, cold particles always settle down. Then at A, high temperature is possible, but not the low temperature. Please note it.
Yes, sir.
Yeah. Okay. Let's move to the next question, children. I'm not marking it that the question number 12 answer is children D. 13th question. The air in a room is heated by a heater. The diagram shows the circulation of the air in the room. Which statement about the air that is heated is correct? Look at the convection process and how it is taking place. Air contacts? No. Air contact expands actually. Air contacts? No. In C and D, if you see, air expands, yes, and becomes less dense. Both are correct. Air expands and its density decreases. What about in D option? Air expands, this part is correct, but and becomes more dense, that part is wrong. So the right answer is children C. So Jenny said that the for question number 13 answer is C. One more question, children. How much time is there for this meeting? 1.5 minutes. Okay. Question number 14. Four rods are made from different metals PQRS. The rod has given equal length and equal diameters. The rods are heated at one end in the same way. The table shows the time taken for the temperature at the other end of each rod increased by 1 degree Celsius. Which metal is the best conductor of energy? Best conductor of heat, best conductor of thermal energy is that metal which take lesser time to reach to the other end and increase the temperature. So here there is a problem with the option children. They said metal P take 3 seconds, Q also take 3 seconds. So answer is R, P and Q. But in the options, P and Q are not given together. So let me mark. So the time taken by P is 1 second, time taken by Q is 2 seconds, and by R is 3 seconds, and the last metal is 4 seconds. So by that option, I can say that the metal P has taken the lesser time to transfer the heat from one end to other and to raise the temperature by 1 degree Celsius. Metal P is the right answer. We will go in this way. Yes, chair, we him. So now I want to end stop this recording also, children. In next class we will continue our questions, please.